Hi students, today we will discuss a problem on Stokes theorem. So coming to the problem, verify Stokes theorem for the field f bar equal to 2x minus y into I bar minus yz square j minus y square z k over the upper half surface x square plus y square plus z square equal to 1 sphere, which is the sphere of radius 1, bounded by its projection on the xy plane. So clearly its projection on the xy plane, and C is the boundary. Now coming to the graph, so clearly the sphere having the center 0 comma 0 comma 0 and the radius is what, 1. So sphere should be like this. So clearly the projection on the xy plane, so since it is xy plane and it is z, if the projection on the xy plane, what we get, look at the circle. If you project on the xy plane, we will get circle like this. Now coming to the problem, we know that from Stokes theorem, what we get, the line integral along the curve C f bar dot dr bar equal to the double integral over the surface S n cap dot curl f bar into ds. Now from this, f bar is what, this one, so that we need to find f bar dot dr first, f bar dot dr bar. So clearly r is what, r bar equal to xi plus yj plus zk, so that what about dr bar is dxi plus dyj plus dzk. So this is what, dr bar. Then f bar dot dr bar is equal to, so f bar is what, clearly that is 2x minus y into I minus yz square into j minus y square z into k dot, so dr bar, so dr bar is what, dxi plus dyj plus dzk. Now coming to the dot product of these two, so I bar dot I bar is what, 1, so that it is 2x minus y into dx minus yz square into dy plus, sorry, minus y square z into dz. So this is what, f bar dot dr bar. Now coming to the line integral along the curve C, f bar dot dr bar equal to 2x minus y into dx, line integral along the curve C, 2x minus y into dx minus yz square dy minus y square z dz. Okay, now clearly see, so coming to this problem, so clearly what we said, the projection on the xy plane, if it is the projection on the xy plane, then what we get, z equal to 0 in the xy plane. So clearly z equal to 0. So if z equal to 0, since z is what, 0, why, because the projection on the xy plane, z equal to 0, then what we get, the line integral along the curve C, 2x minus y into tx only. Why, because here we have z, it is 0 and it is 0. Since all the two values are 0, then 2x minus y into dx only. Then coming to the boundaries along the curve, now coming to the, so curve along C1, so why, because it is the projection on the xy plane, since the z equal to 0, then This represents the circle having the center 0, 0, and the equation of circle should be like this: x square plus y square equal to 1. The circle equation is x square plus y square equal to 1. What are the parametric form of the circle? Is x equal to r cos theta. R is what? 1, so it is x cos theta. Y equal to r sin theta, which is nothing but sin theta. So that replace x with cos theta and y with sin theta. And coming to the boundaries, so clearly boundaries of theta, then clearly theta starts with 0. It is a complete closed curve, so that it starts with 0 and ends with 2 pi. Starts with 0 and ends with 2 pi. So we need to find the value of dx also. So that dx is what? The derivative of cos theta. It is minus sin theta into d theta. Now substitute the boundaries here. The line integral from 0 to 2 pi, which is a closed curve, from 0 to 2 pi. 2 into x is what? Cos theta, minus y is what? Sin theta, into dx is what? Minus sin theta into d theta. Now, so clearly take this. So from 0 to 2 pi, so minus sin theta into minus sin theta is what? Sin square theta. Minus sin theta into 2 cos theta is what? Minus 2 cos theta sin theta. Take positive one as first and the negative one as second. So minus sin theta into minus sin theta is sin square theta, minus 2 cos theta sin theta into d theta. Now from 0 to 2 pi, so sin square theta can be rewritten as 1 minus cos 2 theta by 2 minus 2 cos theta sin theta can be rewritten as sin 2 theta, and from d theta. Now split this one. So integration of 0 to 2 pi, it is 1 by 2 minus cos 2 theta by 2 minus sin 2 theta. So like this we have to split this condition. Now coming to the integration, so for 1 by 2 it is theta by 2 minus, so 1 by 2 is a constant, put it outside. For cos 2 theta, integration is sin 2 theta by 2 minus, for sin 2 theta the integration is minus cos 2 theta, so that minus of minus we have plus cos 2 theta by 2. The boundaries are from 0 to 2 pi. Now coming to the upper boundary, it is 2 pi by 2 minus, so by 4, so 1 by 4 take common, into sin 4 pi plus 1 by 2 is a constant, so it is cos 4 pi, and then minus of, now substitute 0 here, so clearly what we get, so 0, so then what about this? Sin 0 is what? 0, cos 0 is what? 1, so that what we get? 1 by 2, 1 is the lower boundary, so 0, 0, 1 by 2. Now 2 gets cancelled, pi minus sin 4 pi is what? 0, sin n pi is 0 where n belongs to z, so that sin 4 pi is 0, plus 1 by 2 times of 1 cos 4 pi is 1 minus 1 by 2. So minus 1 by 2 plus 1 by 2 gets cancelled. Finally what we get? Pi. The same way, coming to the Stokes theorem, what is RHS? Which is, so double integral over the surface S n cap dot curl f bar into ds. So here we need to find n cap. So clearly n cap is equal to k. Why? Because it is on the xy plane. If it is in the xy plane, n cap should be equal to k, projection perpendicular to the xy plane. N cap is what? The unit vector perpendicular to the xy plane, which is k. Now we need to find curl f first. Curl f bar equal to, we already know that it is I bar j k. So dou by dou x, dou by dou y, and dou by dou z. then PQR. So what is P? So from this we have three values. What is P? 2x minus y. What is Q? Minus yz square. What is R? Minus y square z. Now we have to find the determinant. For the first one, I bar times of. Now eliminate the row and column. If you want to differentiate with respect to y, so dou by dou y of minus y square z, treat z as a constant, and for y square it is 2y. So that clearly, see this, z is constant. For y square minus y square it is minus 2y. And then next, this one is over. Now coming to this one, so it is minus of, yeah, dou by dou z of minus yz square. If you want to differentiate with respect to z, treat y is constant, so that minus of minus is what? Y. Then coming to the z square, it is 2z. Now minus j, yeah. Now eliminate this one. So dou by dou x of minus y square z, completely this is a constant one. Why? Because we need to differentiate with respect to x, so that it is 0 minus. Now coming to this one, dou by dou z of 2x minus y. So if you want to differentiate with respect to z, but here we have 2x minus y, treat as a constant, so that it is completely 0 plus k times of. Now we have to, if you want to take k, cofactor of k, put just like this. So dou by dou x of this one, so with respect to x, these are the constants, so that it is 0 minus. Now again, dou by dou y of 2x minus y. So for 2x it is 0, minus y it is 1. So 0 minus 1. Finally, minus 2yz plus 2yz gets cancelled. So it is cancelled out. So minus of minus 1 is plus 1. Simply it is nothing but k. Finally, curl f bar is equal to k. N cap is what? K. So k bar dot k bar into ds. Finally, so the double integral over the region. So clearly here the region, sorry, so here the region we need to integrate is on the xy plane. Clearly the region is what? Circle. So this is the circle. So the region of, so k bar dot k bar and then dx into dy. This is what? Dx into dy. So clearly k bar dot k bar is what? 1. So that integration, double integration along the region dx into dy. So clearly double integration over the region r times of dx into dy. So clearly where r is what? Is the region in xy plane bounded by what? Circle. Then what is the meaning of double integral over the region r in terms of dx into dy? Clearly it is the area of the surface. Okay, area of the surface. So clearly, which means that what is the area of the surface? Clearly, what is the surface? Here we have circle. That means we need to find the area of the surface, means we need to find the area of the circle what we have. So clearly, what is the area of this circle? Why? Because this is the region, we need to find the integral, double integral. So which means that we need to find the area of this circle. So clearly, so double integral over the region or dx into dy equal to clearly area of circle of x square plus y square equal to 1. Why? Because here z is equal to 0. In xy plane z equal to 0. So clearly what is the area of circle? Pi r square. What is the area of circle? Pi r square. It is the area. So clearly r is what? 1. So pi into 1, that is, so pi. So what is LHS? It is pi. What is RHS? It is pi. So that LHS is equal to RHS. Since if LHS is equal to RHS, then Stokes theorem is verified. Okay students, thank you.